In previous class we have seen this keyword. Now let us see static keyword. Let us take this person class. To make it simple, here we are using only two instance variables, name and age, and this is the constructor to initialize the name and age, and this is the instance method to print the details of that person. In this person demo class, we define two objects, person1 and person2, with this data. Here we are calling print details method on these two objects, person1 and person2. If we run this, we got this output. Suppose I want to add nationality for all of these persons, then we need to add one more instance variable. Here for all of these objects, nationality is same. Then let us set its value in the constructor. Nationality equal to Indian. For this variable, we are not using this keyword since here we do not have any naming conflicts. Here this name and age both are local variables. They will hide the instance variable. So here we are using this. But here we have only one variable, instance variable nationality. So no need to use this keyword. Let us run this program again. We need to print nationality also. Let us run again. Then these two objects got this property nationality Indian. Suppose if you have many number of objects, why to store this property nationality this many times in each object? This property is common to all the objects. If we make this property as static, then it gets memory only once in the class area at the time of loading the class. If we declare this property as static, it makes our program memory efficient. If we keep nationality as instance variable, for that memory will be created within each object in the heap area like this. If we make nationality as a static variable, then memory will be allocated only once within the method area. Now this nationality is like global variable for this person class, which is available for all these objects. Now all these objects can access this single copy. We can visualize these variables in various memory areas like this. All the static variables will be stored within the method area. Objects and corresponding instance variables will be stored within the heap area. For every method, JVM create runtime stack including with the main. That method's local variables will be stored in that stack. We have two reference variables, person1 and person2. They will be stored within the main method stack frame or main method activation record. These stack frames or activation records will be stored within the stack memory. Next instruction to be executed will be stored within this program counter registers. Native method invocations will be stored within the native method stack. Native methods are methods which are written in other than Java. Let us take another example. To implement a counter that stores the number of objects created at given time. Means I want to count how many number of these objects are created. That counter is also not specific to any object. To represent the data which is common to all objects, just we need to precede its declaration with the keyword static. You can declare both methods and variables to be static. When a member is declared as static, it can be accessed before any objects of its class are created and without reference to any object. Variables declared as static are essentially global variables, but its scope is within the class. When objects of its class are created, no copy of static variable is made. Instead of that, all instances of the class share the same static variable. Remove this statement from the constructor. Let me declare one more variable which counts the number of objects created. Default initialization is applicable to static members also, like instance members. We can declare static block. That static block executed exactly once when the class is first loaded. Let me define static block to initialize the static variables. Static block can be defined with this static keyword. And initially person count is 0. So this is the static block. These two are static variables. Let me define one more static method to print the static data. Like instance variables within the same class, we can access the static variables with simple names. Within the static method, we can use only static variables. If we define instance variables, then we will get error. Suppose if I try to print the instance variables name or age within this static method, then we will get the error. See here, cannot make static reference to the non-static field age. We are getting this error, cannot make static reference to the non-static field. So let me remove this. For this both static variables, nationality and person count, memory will be allocated in the context of the class, but for this instance variables, memory will be allocated within the heap. Within the same class, we have used simple names to access the static variables. Suppose if I want to access the static variables outside of this person class, I can access these static variables outside of this person class without object reference. To do so, we need to specify name of their class followed by dot operator. This is the general form to access the static methods. If it is a static variable, just class name dot field name. Here, this class name is the name of the class in which static methods are declared. This format is very similar to that used to call non-static methods through this object reference. A static variable can be accessed in the same way by using the dot operator on the name of the class, like person dot Similarly, we can call the static method with class name person. Then let us run this program. Here first we set the nationality to American, and then we are printing the static date. Here initially person count is 0 and nationality is American. Then we call this instance methods. Let us see this print details method. Here we are also printing that nationality. There it was set to American. That's why these two objects got the same value for nationality American. Means that static variable data can be shared among all the objects. Let us see the execution flow. When we try to create the person object, this person class will be loaded. Then first static variables will be allocated memory in the context of the class. Then static block will be executed first. In that this initialization will be performed. After that these two objects will be created. Then we are overriding that nationality with the American. Then we are printing the static data. That static data can also be available to the objects. That's why we are printing that nationality here also. If I print the other value, let me print person count also here. Let me comment this, then we will get the nationality Indian. Here we got the person count 0 for two objects. It should be incremented. So let me increment when the new object is created. See here, when we access this person count, here person 1 and person 2 we got the same value. Means while creation of this person 1 object, that count will be incremented to 1. When we run this statement, then person 2 will be created. That person count is static variable, so only one copy will be maintained. Again that will be updated from 1 to 2 with this statement. That is why after completion of these two statements, we got the person count value 2. That's why when we try to print the person 1 details, we got the person count 2. Within this second method call also we got the same person count value 2, since it is a shared variable. Similarly, this nationality also. The most common example of static method is main. Main is declared as static because it must be called before any object exists. Static methods have several restrictions. They can only directly call other static methods of their class. they can access only static variables. They cannot refer to this or super. This will call current class constructor, super will call super class constructor. Constructors will be called while creation of the object, but static methods will run before creation of the objects. Instance methods can access the static variables and static methods. After executing static methods, JVM creates objects, so instance variables or methods will not be available to static methods. Here, this is the instance method which is accessing the static variables, but if we try to access the non-static data here, we will get the error. Here we are getting error, cannot make static reference to the non-static field age. Static data is common for all objects, but non-static data, that name and age, is different for each object.